So this is 3.2, B as in boy, in elementary algebra. We're going to continue on with graphing linear equations in two variables. So we have an x plus y equals 5, and it's asking us to graph that. So first of all, what we're going to do is make our handy-dandy little chart here with an x and a y. So let's say we put a 0 in for x. That means y has to be 5. We put a 1 in for x, y has to be 4, because 1 plus 4 is 5. Then I look and see if I can find some negative ones, because that kind of is always good. You always pick 0, a positive number, and a negative number. So let's pick negative 2. So if x is negative 2, what is y going to be to give me 5? Well, let's add 2 to this side, add 2 to this side, so y has to equal 7. Alright, and all I need are 3 points. Once I get my 3 points, I can graph it. So let's graph it in green. So 0, 5, 1, 2, 3, 4, 5. We went over 0 and up 5. At the next one, we went over 1 and up 4. Next one, we went over negative 7 and up, or negative 2 and up 7. Alright, that gives me a straight line that looks like that. And that's how you graph these. You have to get a straight line. If you do not get a straight line, if for some reason you had a point over here and when you drew this it went like that, you know you did something wrong, because it has to be a straight line. Alright, so that is example 4. And let's continue on with example number 5. Example 5, they're asking us to graph y equals 3x minus 1. Alright, so first of all we need to make our little table. And let's use 2, 0, and negative 2, because you're only going to find 3 points. So we put 3 times 2 minus 1, so that's 6 minus 1, that gives me 5. 3 times 0 minus 1, so this is 0 minus 1 is negative 1. This one is 3 times negative 2 minus 1, and this is negative 6 minus 1, that gives me negative 7. So that gives me my 3 points. Let's bring our graph back up here, make it a little bit bigger so I can actually put my dots in the right places. 2, 1, 2, 3, 4, 5. 0, negative 1. Negative 2, 1, 2, 3, 4, 5, 6, 7. So then my line gets drawn, and again it's a straight line. Boy, I'm good at straight lines. And there's your graph of that equation. Let's look at example number 6 here, and we'll get this out of the way again and try clean up our board. Example 6 says graph 3x minus 2y equals 6. Okay, the thing that makes this one different is we don't have a variable on one side of the equal sign by itself. That really makes life easier. So let's move our y value to get it by itself. So let's move the 3x over. So I have negative 2y equals negative 3x plus 6. So we're just going to put all these together. Divide by negative 2, divide by negative 2, that goes away. So y equals, and then we're going to split them up. Alright, so let's reduce or simplify these. So y equals positive 3 halves x. And this negative sign here makes this a negative 6 over 2 is 3. Okay, so we've got all that information. What I need is what I have left right there. The rest of it can go away because we just changed that to that. Now we can make a handy-dandy little table. And again, we're going to put some numbers. Let's say I put 3 in for x. Then I'd have 3 halves times 3 minus 3. So I'd have 9 over 2 minus 3. Yuck. I don't want to deal with a fraction. So when I have a fraction as my slope, or as, you know, the number in front of my x there, if I decide on an x value that is a multiple of 2, that will get rid of the fraction. So for example, let's say a multiple of 2. Let's say I make x 4. That means I have 3 halves times 4 minus 3. 3 times 4 is 12 over 2 minus 3. 6 minus 3 is 3. So see what happened? The fraction disappeared. So anytime you take a multiple of the denominator for the number you plug in for x, your fraction is going to disappear. Let's use 0. If I put 0 in for x, then that's going to give me 0 minus 3. Alright, and for another x, let's use another multiple of 2. Let's use negative 6. So now I have 3 halves times negative 6 minus 3. So negative 18 over 2 minus 3. Negative 18 over 2 is negative 9. Negative 9 plus a negative 3 is negative 12. So see, I got rid of my fractions and it's a lot easier. Alright, so let's graph this thing. Get my graph moved over here a little bit, make it a little smaller. So I'm looking for points, and let's do this in red. Let's do 4, 3. 1, 2, 3, 4, 1, 2, 3. So there's 1 point. 0, negative 3. I don't go over left or right, but I go down 1, 2, 3. Next point, negative 6, negative 12. 1, 2, 3, 4, 5, 6. And then I go down 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Somewhere down in there. And I draw my line. And there's my line that I have. Alright, so that's example number 6. So for example number 7, it says graph each of the following lines. So A is 1/2, y equals 1/2 x. So they want us to graph that. Alright, so what do we know here? Let's go ahead and put a graph on here. And a lot of this will come as you practice. So the slope-intercept form is y equals mx plus b. Remember what b stands for? The y-intercept. That's where it crosses the y-axis. There isn't one over here, is there? There's nothing added to that 1/2 x. But if you were to put something, you'd put a 0 there. So that means it crosses the y-axis at 0. Okay, so next thing we're going to do is find some other points. So we can put some x's and y's in there. Let's put 4, because that's a multiple of 2. So that gives us, in fact, let's move this down. Multiple of 2, so 1/2 4 is going to give us 2. Let's put 8 in there. 1/2 8 is 4, and let's put negative 4 in there. 1/2 of negative 4 is negative 2. Alright, so let's graph this. So we have 4, 2, 1, 2, 3, 4, up 2. We have 8, 4, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. And then I have negative 4, 1, 2, 3, 4, down 1, 2. And then I draw my line. So, not really anything weird about that, but when we get to this next one, the B portion of example number 7, we do hit some weirdness. So let's go ahead and look at that. It says x equals 3. What that means is my x value is only 3. It will not change. So where is x equals 3? 1, 2, 3. What point is that? That's 0.30. Am I given a y value? No. So that means my y can be anything I want as long as my x is 3. So whenever you have something like x equals a number, that number is going to be a vertical line at that point. X equals 3. The same is true with y equals negative 2. So I'm given a y value of negative 2, but I'm not given an x value. So, oops, I'm sorry, I put the point at the wrong place. Y equals negative 2, down 2. But I'm not given an x value, so x can be any point at all along this line. So when it says y equals a number, you always get a horizontal line at that number. Alright, so that's it for lesson 3.2.